Hello, in this lecture, I am going to discuss about the one of the type of the shift register that is called as parallel in serial out. So here if you see that on the top of this, that is the data is given as the input that we have here parallel in. Now if you see that here we have taken uh, four flip-flops here and we are taking the D flip-flop, and here if you see the clock pulse, in the clock pulse here bubble is used. That means whenever there is the transition from the where to where, when it is going to change from the 0 to 1. So in case of 0 to 1 means that will be the positive edge trigger. But here bubbles is provided. So whenever transition will takes place from 1 to 0, then these flip-flops are going to trigger. So that means it is going to use the negative edge trigger. Which type of the trigger is this? Negative edge trigger. Since here bubble is applied and whenever clock will change from the 1 to 0. So now we'll see the operation of this. So here if you see that we have AND gates and output of AND gates are given to the OR gate. Similarly, for all three flip-flops, connection is made like this. So now here, if we'll take shift as the 0. So when initially we want shift should not takes place. So just we are taking shift as the 0. So finally here if you see that inverter output is going to be 1 here. And if you see that here MSB bit is connected directly to the flip-flop 3, what is marked here 3. So that connected with the MSB bits here. Now here since inverter output is 1, so finally if you see that AND gate G1, AND gate G2 and AND gate G3. So these three AND gates have one input as the 1 due to shift and another input is the data inputs. So whatever data inputs we want to send here, that is going to be the high here. So finally, both inputs to the gate G1 is high. So finally, this G1, G2, G3 will produce the logic 1 output and which is going to be stored at the input of the each flip-flop like D2, D1, D0. Next, we'll see that when if we are going to take shift as the 1, then what is going to happen? So when we'll take shift as the 1, so if we'll see that this inverter output is what here? 0. So due to that, one of the input to the G1, G2, G3 is 0. So finally these three AND gates, that is the G1, G2 and G3, that is going to produce the output that is the logic 0. So that AND gate is, those AND gates are disabled. Now since shift is 1 here, so that is, we'll see that it is connected to the G4, connected to the G5 and G6. And another input to this gates G4, G5 and G6 are what? The output of the flip-flops. Okay. So here earlier here for the D3 already MSB bit is here. So when triggering takes place, now shifting is going to occur. What is the data bits here at D3 that is available at the Q3? And this finally in the next clock pulse, what is happening here? This Q3 will be input to the G4 and this Q2 will be input to the G5 and Q1 is going to be the input to the G6. Like this, datas are being shifted towards the right. And from the last flip-flop, that is the rightmost flip-flop, will get the data output. First data output will get from here. So like this, consecutives, inputs will be taken here for the different clock pulse. For again, finally, we are going to get the output here. So that is the benefits in the parallel in and the serial out. So finally, we can conclude this one that whenever we have shift as the 0, when shift is 0, that means what is happening here? Gate G1, that is AND gates G1, G2 and G3 going to produce the logic 1, that is the data inputs, and whenever and in that time when shift is 0, so what we'll see that here G4 and G5 and G6 are going to produce the output, that is the logic 0, means these three AND gates are disabled. And second situation, what we have seen, when we have shift equal to 1, then reverse of this going to take place. G1, G2, G3 having one of the input as the 0 due to shift 1. Since these three AND gates are connected with the inverted output of the shift, so it has output as the logic 0. That means these are disabled. And at this time, AND gates G4, G5 and G6 are enabled. That is going to produce the output logic 1. So here at this situation, shifting will take place, and when shift equal to 0, here loading is going to take place. So data will be loaded at the input of the flip-flop, and when shift is 1, yes, shifting is going to take place. Like this, we are able to explain parallel in, serial out. Thank you.